Let's talk about polyatomic ions. So polyatomic ions basically are, as it sounds, multiple atoms. All right, multiple atoms. In this case, they're ions. Okay, so let's look at a couple. Let's look at a couple here. Let's look at a couple. So this is a list of your ions here, the most common ones. One thing you want to pay attention to is that most polyatomic ions are actually what we call oxyanions. So basically, a lot of these have oxygen in them, and we can see, right, majority of these actually do have oxygen in them. I don't really got any cool thing, right, to get you guys to memorize that. I don't got no song or something for you. I'm just going to tell you, right, what you need to be paying attention to. Okay, because if you know the structure, if you know the rules for these, then you'll be straight. Okay, so let's talk about this first thing here. ITE, ITE. So ITE, and once again, most of these are anions. Okay, but ITE means that the anion is going to have less oxygens. If it ends with ATE, this means that it's going to be the one with more. So let's pick out an example here. Let's look at nitrite and nitrate. Okay, so nitrite has not an N here, right, for nitrogen, right? And same thing here, nitrate. Now, ITE means that the anion with less oxygens. So nitrite only has two oxygens. Nitrate, ATE, has three oxygens and NO3 here. Okay, so we can see that difference, right? Anytime, right, if you got a similar compound, nitrate in this case, the one that has ITE will have the less amount of oxygens. The one that has ATE, right, means that we're going to have more oxygens. Okay, and like I said, I don't got no fancy song for you, nothing like that. It's just ATE is more, ITE is less. All right, you could think of it as, oh, I just ate, so I got more. ITE is like, I'm all right, so I don't need nothing. I don't know. Okay, so nitrate more, nitrites less. Okay, now let's look at one other rule, because we have what we call a series of these. All right, so you can have an ion, all right, and that ion can have a lot of oxygens or not a lot of oxygens. That's the main difference between these polyatomic ions. Okay, some of them have a lot, some of them don't have a lot of oxygens. So basically, if you got a series, right, hypo means less, right? And if we think about hypo, right, hypothermia, all that type of stuff, you think about the meaning of hypo is low. So hypo in this case will mean less. We have the least amount. Per, per in this case means that we have more, right? Hyper. So if we think about a series, in this case, let's think about the series of our polyatomic ions that has chlorine in them. Okay, the chlorine with the oxygen. Let's look at this first one here. Hypochlorite. Hypochlorite. So hypochlorite is letting me know that, okay, I only have one oxygen. Okay, so it's less. So basically, hypochlorite, we have the least amount of oxygens. How do we know that exactly, Dr. J? Let me go over that again. Hypo, less, and then also ITE. ITE, remember, means the one with the less oxygens. So when we go forward, right, and say we gain another oxygen, now we're at ClO2, we have a chlorite. Chlorite, right, has less oxygens than chlorate, but it has more oxygens than hypochlorite. And if we go more, right, if we add another oxygen, now we have chlorate. All right, and then this just goes back to our two here. ITE means less, chlorate means more. Okay, so in this case, the chlorate, we're going to have ClO3. Okay, and then the one with the most oxygens, perchlorate, ClO4, right? So per means that we have the most, and also pay attention to the 8. That means that we have the more, right? So perchlorate, we're going to see 4 oxygens here. Okay, another example of that is permanganate. Okay, we got the 4 oxygens here. So these rules are really the key thing here, right? And you can tell, right, which one you really have. If it's an ITE, you're going to have less of an amount. If it's ATE, you're going to have more. If it's hypo, you have the least amount. If it's per, you have the most amount. Okay. Now, these polyatomic ions, like I said, is very good just to start looking at these and get them in your brain, right? And just review them over and over again. But if you know these rules, even if you're not sure, if you know that you see an ATE, okay, expect to see this one has more oxygens. If you see ITE, okay, this one has less oxygens. If you see a hypo anywhere, this is going to have the least amount. If you see a per, it's going to have the most amount, right? And let me just cover a couple ones. Hydroxide. This is a big one that you guys will need to know, and that's used often. So it's OH. And then also, one thing that I want to point out is that these are ions. So ions have charges. Most of these, like I mentioned, are going to be anions, so expect to see a negative charge. For instance, if we go back to the chlorine oxygens here, the charges are not changing. The amount of oxygens are changing. So hypochlorite, chlorite, and perchlorate all have the same charge, -1. All right, so they're always going to have the same charge. The only difference is the amount of oxygens. Okay, amount of oxygens. Now, there are a couple of these polyatomic ions that are not anions, they're actually cations. So that means they have a positive charge. The one that's on this list is ammonium, all right, NH4 plus. So this has a positive 1 charge for ammonium. Another one is mercury. I don't think, yeah, that's not on this one. All right, but ammonium is a positive charge. And this is one that you definitely want to know. This is a very common one, okay? So can't stress this enough. Can't stress this enough. 8, you got more oxygens. IT, you have less oxygens. Hypo, the least amount. Per, the most. I don't have a cool song for you guys. Just get to reviewing these. Okay, that's as much as I can say for polyatomic ion.